Okay, so this is going to be pretty tough. When we have x's in the base here and the power, that always means that, let me write it for you over here. X's base and power. We're going to ln both sides. It's always what we have to do. Ln both sides. Okay, so I go, all right. So I'm going to grab just this for starters. I'll bring in the limit in a minute. Let's just, okay, 1 minus 3 over x to the x. So I'm going to have to ln both sides. So I'm going to go ln of y equals. Okay, and then just grab that and bring it down. That's why I love natural logs, because, or any log, because the greatest property of the log, powers come down to the front. So then what do we get? We ln y is x ln 1 minus 3 over x. Okay, now what are we going to do from here? Well, let's don't forget that we really have a limit here. So let's take the limit. X goes to infinity. Now, if we plug in infinity right now, infinity goes there, infinity goes there. It's not going to be a good plan because it'll be infinity times ln of 1 minus 3 over infinity. That's infinity times ln of 1 minus 0, right? 3 over infinity, 0, right? Because 3 over infinity is like 3 over a million or whatever. Like x, if x is going to infinity, infinity is like a million. So I said I'm going to give you, to take candy bar, cut it in a million pieces, give you 3. That's just nothing. That's basically 0. All right, so this is 0. So then this is infinity times ln of 1. Now what's the ln of 1? You can check it on Desmos if you're not sure. There it is right there in the middle. Ln of 1 is 0. So this becomes times 0. What's infinity times 0? It's indeterminate. I mean, we can't determine it. We don't know. You might think, yeah, anything times 0 is 0. We know that. No, well, problem is, I mean, that's true. Yeah, but this isn't really a 0. It's just close to 0. Remember, as x goes to infinity, million, billion, trillion, this gets close to 0. And so then ln of 1 minus 0 is close to ln 1, which is close to 0. It's really just a super tiny number, close to 0, but not really 0. Times a really big number. Really tiny times really big. We don't know what that does. It's unclear. It depends who's bigger and who's smaller. So, okay, what do we can do then? Well, this is where I think I'm going to add Lopi, give you a hint here. Lopi to this one. So when you do Lopi, which we're going to need to do, what does that mean? That means when you have 0 over 0 or infinity over infinity, then you're going to take the derivative, deriv, deriv, I'm getting lost, derivative of the top and the bottom separately. Separately. So you're going to take the derivative of the top and the bottom separately when you have 0 over 0, infinity, infinity. Separately. That's the key word, separately, because it's not quotient rule, separate. Okay, so when can you do that? Only when you have 0 over 0, infinity, infinity. So that means when we look at this, we go, okay, we're getting infinity times 0. That's unclear. What are we going to do? Well, that's when you've probably seen this before. What do we do? We're going to make a big fraction out of it because we got to get 0 over 0, infinity, infinity. So I'm going to go LM, so leave that where it's at. 1 minus 3 over x. And then this x down here, on the top, I'm going to flip it to be 1 over x on the bottom. Are you good with that? X on the top is the same as 1 over x on the bottom, right? Dividing is upside down multiplying. So to multiply by x is the same as to divide by 1 over x. Why? Because you could flip it back. It'd be x over 1, be back to the same way it was. Now, why is, okay, you might go, all right. So why is that so great? Well, because now if I plug in infinity, say here and here, what are you going to get? You're going to get ln of 1 minus a over infinity, or 1 over infinity. And that's ln of 1 minus 0, or 0, right? Because 1 over infinity, 3 over infinity, there's a 0. That's ln 1 over 0. All right, I'm getting a little scribbly. This is ln of 1 over 0, which is 0 over 0. And we go, oh, Lopi. So as you see 0 over 0, you say, okay, now we can use, if you get 0 over 0, So now use L'Hopital's rule. Because we got 0 over 0, infinity, infinity, right? That's the requirement. To use L'Hopital, you got to have 0 over 0, infinity, infinity. Then what can you do? You do the derivative of the top and bottom separately. So I go, okay, okay. So now I'm going to go equals, okay, let's here, equal, I'll put an H to say I'm using L'Hopital because of L'Hopital that I can do the derivative top and bottom separately. So here we get, this isn't easy. So let's take the derivative of this guy, 7. Now what's that? Well, it's 1 over the argument, right? That's right, but I just want to make it bigger for you. This is just an ugly. Okay, I go with the same color. So it's 1 over, yeah, let's take this, right? That's how you do derivative of natural log. 1 over the argument, be careful, times the derivative of the argument. Because chain rule says if the inside is anything other than a simple x, you gotta do chain rule. So now I'm going to rewrite that just to make life easier. 1 minus 3x to the minus 1. That's what that is, right? So the derivative of that then, with chain rule, right? Chain rule. Here it tells me, derivative of that, what's the derivative of that? Bring that, the 1 to 0, bring that minus 1 down, plus 3x to the minus 2, subtract 1 from the power, right? On the bottom, let's do that. I'm going to rewrite that as x to the minus 1, derivative, bring that minus 1 down, minus x to the minus 2. Whew, all right, we good? Now, look at this. Bye bye. Don't forget that negative still there though, and the 3. I'm just going to let that negative float on up, right? Because positive or negative, whatever, no matter where it's at, let it float on up. Limit. This goes to infinity. What do we, well, how about maybe I'll just leave it down there, whatever. I'm going to plug in infinity. This problem is almost done. It's just a big, ugly mess, but actually, it's not that messy. What do we have? I'm going to plug in the infinity right here. So I'm going to get, okay, I go 1 minus 3 over x times positive 3, and I'll put it over minus 1 on the bottom, whatever. Put that down there if you want, whatever. Okay, I'm going to let x go to infinity. So put that infinity in. Boom. So what's that? 1 over 1 minus 3 over infinity times 3 over negative 1. This is 0, right? Because anything over infinity is 0. So we did the limit. So this is 1 over 1 minus 0 times 3 over negative 1, which is what? 1 over 1 minus 0 is 1 over 1. 1 times 3 over negative 1, which is negative 3. But careful, that's not our answer yet. Remember, all along, this is ln y. Right, so at the end, whenever we do ln both sides, whenever we do ln both sides, at the very end, we go, okay, so now I've got ln y is negative 3. I got to get rid of that ln y, e both sides. Bye-bye. So y equals e to the minus 3. So here's what you do at the end. That's the answer on this, or 1 over e to the third, same thing. That's how you have to end those. And so there we go.